All right, welcome to this video. Today we're going to talk about notification service, and in particular, webhooks, and how they're important. So we'll get started with the example. Uh, when you're ordering food on Uber Eats and you get that push saying, your driver picked it up, that's a notification. Uh, Another example is like, hey, uh, maybe something a little bit more concrete is if you order Domino's pizza a lot, like me, Domino's number one. Uh, they have that pizza tracker on the website. Now, if one way to implement that is to implement polling, which is as a client, me, if I have to hit the pizza service every 5 seconds, uh, within a few minutes, I could rack up 100 requests. And as you know, like a pizza delivery usually takes about 15 minutes. So you can just imagine how many requests that this pizza service has to support for a single customer. Um, so this feels pretty wasteful. So what could we do instead? Well, one option we have is that instead, um, maybe there's a better way for us as a client to know when the status is updated. So instead of polling the service, the pizza service could respond to the client and say, when the status has been updated, it'll push to the client one time, so a single request, uh, letting you know, all right, we're getting ready for delivery. So this reduces the traffic, as you can immediately see, uh, 100 to one request. And this allows our pizza service to be able to handle um, a lot more clients. So let's go ahead and jump into the problem here. So this notification service, as I was doing the system design, I wanted to understand the concept hands-on. So I built a little, the goal is to build the notification service with two microservices. One will be simulate a provider, so something like Twilio, uh, which would handle the actual pushing of your message to, let's say in this case, an SMS. And then the other, which is your notification service, will receive updates via the webhook here, just like, for example, how GitHub might talk to Slack or Stripe talks to your backend. So this is the diagram. We've got a client here. Now, on the service side, the client will send a message to the notification service. This service will create that message in the database and then send that over to send the message over to our provider. Provider will say like, all right, 200, I'm good. And then at some later date, the provider will update the webhook callback provided by our notification service and notify us like, your status has been completed, or maybe there was an error or whatnot, and we can update the database. And similar to a webhook, we'll use a WebSocket, or similar idea here, where now once we got the delivery status updated, our status can move through the WebSocket back to the client. So when we start thinking about like our data, really this is a simple use case. We'll just have a message table, UUID, text, status. You'll notice here I'm not doing any idempotency. So for example, if there was like a network failure between notification service or provider, to where it accidentally got two or multiple requests go through to the provider, I'm not keeping track of like a job ID to make sure that we don't process the same message twice or three times. This is just a simple demonstration. Now API wise, for our notification service, of course, we've got send message, so this will actually create the message. We have a get request so that our client can actually see what messages are available. And finally, we've got this webhook callback. So this is the important part of the webhook. This is a provider callback, is what we're naming the route. And this will receive a message ID and the status. And this is what we will actually send to the provider itself. So you'll see here on a provider service, this accepts a API/send, and you can see here it takes in the message that we're sending, the actual text, the message ID, the text, and finally the callback URL. So this callback URL is this /API provider callback. That's what allows us to return and update the delivery status. So that's how our provider knows, okay, this is, we should call this thing when we're done. So cool. That's our whole API. Let's jump over to the code. So let's jump into the pie chart now. I'll show you the UI real quick here. This is essentially what we'll be looking at. So we've got a page. We can enter some messages. We can send them. And then we can see the status of whether it's pending, delivered, or error. So with this in mind, maybe let's take a look at the code. So first things first, we've got, I talked about it briefly, but we are going to, every time a client opens up, we're going to have a dedicated WebSocket for them. We've got load messages there, and then we'll load our messages onto the page. This will be static because I wanted to keep things simple. Our database.py, these are simply, you can see here we're using Postgres, and these are SQL queries. So if we want to get the latest messages, create a message, update the message status, simple. We'll skip over the Docker file and let's move to the main.py, which is like the meat of this. So you can see here, simple FastAPI app. We're serving static files. When you get to the root, we'll serve index. So this is our get messages route, but the cool stuff is right here in create message. So when we create a message, we're going to update our database, and then we'll actually call the provider asynchronously with our VUID and our the actual message to send. And we have this going as a background task. Now, the call provider, as you can see here in the payload, takes in the message, the text, and you'll notice this callback URL. So we're actually going to send that over to the Twilios, and we'll expect the provider to call to send its response back to this URL. So similarly, if we go into the provider and we check out the route, so this is our send message route here, and you'll see it's adding a background task or process message, which is this. To simulate the provider, we have a 2 to 5 second delay, and then about 85% of the time we'll return with success. Otherwise, we'll get an error, and you'll see that being sent. And the interesting part here, on the response, we're going to do a post request back to this callback URL, which we were fed as we saw it, which is what we were fed from our request. You can see request.callback URL. So once this request is sent, we send back to the services. And here, this is our process provider. This is where we can now update the delivery status for our message ID with whatever status came back from the provider. And then we're going to send an update. We're going to send an update to our client with all of the with the new status for the message. Now, in this case, obviously, it doesn't make sense to do a broadcast like in the real world. In the real world, we might have multiple different users, and so we'd have to decide which WebSocket connects to the correct client so we can send that data over correctly. However, just for this example, we're using a broadcast, and everything here is set up with a Docker Compose. So you can see we've got our Notifier UI on 8000. We pass in our environment variables here. This is our provider, exposing 8001, and then we've got our Alpine Postgres database. um, with all of our necessary values. And then the schema here shouldn't be a surprise: message ID, status, text. And we've got these two indexes, which hopefully you shouldn't need, depending on how many messages you send. So let's go in here, just upload this to Git. There we go. Docker compose up dash dash build. So that's going to go ahead and build all of our images. Once that's all done, see everything here is running. We're going to make this a little bigger. Unfortunately, I can't make the terminals. Can't zoom into the terminal, but if we refresh this, we can see this is our message history. We've got our messages. We're going to focus on the fetch requests. So if I send a message, hello world, you're going to see the message was sent. We sent it, and then we do an immediate response so that we can update the messages. See this returned error. But if we, which is okay, somehow we hit the 15%. But if we check our logs, you'll see how things started. So right here, this was our post to create messages. We call the provider with our payload. You'll see that's our hello world with our callback URL. And then the provider here is going to, it received the message with that hello world. You can see it's sleeping, so that's our delay. And then it sends the request back to our callback. So you can see here, it decided, okay, result failure. I'm going to call the callback provider dash callback. This is its payload with error. And finally, the notifier receives it and broadcasts to two connections. So I know this was pretty small, but hopefully this gives you an idea of what's going on here. Let's try to get a successful message. So go in, we send it, it's pending, and then you can see it's updated to delivered. And on the right side, you can see I'm not polling for these messages. We do have a WebSocket set up. So you can see the WebSocket is up. And so we don't have extra rows here. But yeah, all of this is available on GitHub, so you can see the link below. Everything is available on Notif Webhooks. If you want to, you can clone this down yourself, take a look at the code, and even start the services with Docker Compose up with the web interface. So yeah, that's it for this one. Hopefully this was a quick example of a little bit of WebSockets and how webhooks work. Thank you.